Hello, this is Bill checking in on Paul McWhorters Pico W homework number 18. I'm a little late with this homework, so sorry about that. I hope better late than never. I actually did two different versions of this homework, and so that I hope that redeems me a little bit for being late. Anyhow, the homework assignment was to use an RGB LED, and last week or last homework assignment we did a toggle switch to turn LED on and off. This week we're doing it so we use three different switches to toggle on this RGB LED, and one switch will toggle it red, one will toggle it green, the other will toggle it blue. And this is how I kind of went about it. For machine, import pin and PMW. In this assignment, we probably didn't need to use PMW because the assignment didn't say use, it said turn it on and off. So you could go full blast and off. And so we wouldn't really need to do the pulse modulation. Then from time import sleep, ZZZ from Charlotte, and a delay of 0.1. Then we have to assign GPIO pins for both the button and the LED. I did LED on one side of the Pico chip or board, and buttons on the other side. So for the buttons I use 16, 17, and 18, which is 16, 17, then you skip one for it's a ground, and then 18. And for the LED, I use 13, 14, 15, which is 15, 14, then you, same thing, I believe that's a ground. It's tough to tell from this angle of it. And then the last one is 13. So, and for those, okay, then we have to assign the buttons to those variables that we assigned, to the pins that we assigned. And so I have red button equals pin, button R pin, and then pin in because we're going to read from this, and pin dot pull up is the command that allows us to use a the internal resistor rather than having to pull out another resistor and use hardware to make it work. And green button's the same, blue button's the same. You know, I used R pin here. We could have put in 18, but God invented variables, so that's what we did. And the same thing with the LED pins. We need to assign them to these GPIO pins that we have. So for the RED, the red LED, I have pin equals red LED pin, comma, pin out, because we're going to be displaying what's going on from there. Same thing, green LED, blue LED, same code. Oh, this stuff that's grayed out, I'll show you that on the second part of this homework assignment. But like I said, since it's on or off, we really didn't need to do the duty cycles of frequencies because the duty was going to be full blast on that. Also, if we were going to use the duty cycle on here and do PWN, we would have to include that up here when we assign the button pins here. But I'm going off on a tangent that we don't need to worry about. Then, as we remember from our previous homework assignment, the red LED or the LED state is either on or off, true or false. And then we had to know the red button state is whether the button is being pushed or not being pushed. When it's not being pushed, it's 1, and we set the previous button state equal to 1. And I guess I should switch that, or could switch that, but that's the way I set it up. And you'll see why down here a little bit farther. So we do the same thing with green and blue. Then we start getting into the code. While true, R button state equals R button value. So this means when you push the, or actually it's just reading the value of what it is. So if you push the button, then the value is going to go from 1 to 0, and that will record the button state. And do the same thing for green and blue. And then I put some print statements in here to print the RGB state and the LED value. So it's saying whether the button's being pushed or not, and whether the LED is on or off. And it's something we put in there just to check and see if it's working to this point before we have any more coding to do. Okay, then this was pretty much the same as it was last week. I changed things or did it a little differently than Paul did in his solution, and he didn't state this, but I interpreted that as he either wanted an LED to toggle on or off. We didn't want more than one LED going at the same time. So it's if R button state equals 1, so not being pushed, and previous button state equals 0, so is being pushed, red LED state equals not red LED state. So if we push the button, it's going to switch the LED. It's going to turn it on or off. And then since this was just dealing with the red LED and the red button, I didn't want the green one to be on, so I called it false. The blue one, I wanted to set that state as being false, and then these values just display what we've told it to right above it. So the RED value equals the red LED state, which is either going to be on or off. The green LED value is going to be off, and the blue is going to be off because we told it up here. And then once you go through that loop, we want to switch it. So I have previous red button state equals red button state. And we do the same thing for green, with the exception of, since we're dealing with only the green button, the red and the blue are going to be off. And the same thing with the blue button, only when we're dealing with the blue button, then the red and the green are going to be off. And then I put a delay in there. And you can kind of see down here in the shell what state's going on. So let's, oh shoot, damn it. My camera went off. Let's turn my camera on. Okay, now let's see how this works. I'm going to press the red and you toggle it and it goes off. Push the green, toggle it, it goes off. It's the blue, toggle it, and it goes off. However, so they all toggle, but since I put that thing in there where we didn't want more than one going, if I push the green goes on. If I push the blue goes off, and then we toggle. So there's part one of the homework. Now for my second one, For part 2, I did the same type of thing. Import machine, pin, this time we're going to use PMW. From time, import sleep as ZZZ. The pins are the same, all this stuff's the same, except I put a frequency of 1,000 and the duty cycle on all of them are 0, so it would be off. And I did previous red button state is 1, previous green button state is 0, previous button state is 1. And I put in, excuse me, I put in a counter. The red counter is R, the green counter is G, and the blue counter is 0. And what I was doing on this, oh, rewind a little bit, go back up here. I did a PWM duty. So I had high, low, or off. So each one of those switches, it's either all the way on or all the way off or halfway, or I actually did a little less than halfway just because it looked better. We go down to the while true. Red button state equals R button value, so that just tells what's going on with is the button being pushed or not, or that assigns a state for whether the button is being pushed on or off. So then I have if red button state equals 0 and previous button state equals 1. So this is essentially the same thing we had, and it's checking for if something's been pushed. And then I have R equals 1, so if this changes, R equals R plus 1. If R is greater than 3, then R equals 1. Well, let's keep going. It'll kind of be self-explanatory. If R equals 1, then the LED is on high duty. If the counter is on 2, the second press of the button, then it's going to be low. And if it equals 3, then it's going to be off. And then same thing, we reset it for the next time around. We do the same thing with green, same thing with blue. I print this stuff out just to make sure it's working right. And we have delay, and you can see RGB state, that's red, green, blue. LED state, false, false, false. So nothing's being pressed and all the lights are off. Let's give it a try, see if this works. There's full blast. Oh, sorry, I'm still in the last program here. Let's restart this. Okay, oh, crap. The counter was different. So that last part I said was actually going through the last homework assignment. And this is red counter, red button value, and red button state. So we have 0, red button value 1. Okay, let's give it a try. Let me put this little diffuser thing on there. There's red full blast, red half blast, red off, green full blast, green half blast, green off, blue full blast, half blast, and off. And this allows us to do some color mixing. So you can see there's full blast red and green. There we can alter it a little bit. There's all green, full blast blue. So anyways, this allows us to do some color mixing. I'm not sure how great that shows up on the screen, but that's what it does. Anyways, hope I didn't bore you. Thanks. See you next week.